All right, so again, this is the paper I handed out to supplement the notes packet. This is part 7, which is solving trig equations. So I asked y'all to take a minute to try these. If you're watching this as a video, pause and give these a shot. You can use your unit circle for these, and then unpause to check your work. All right, so here we need to, in these first couple, hopefully those were relatively easy for you. You have to isolate your variable, so you got to move them to the same side. It doesn't matter if you move the 4x to the left or the 5x to the right, you just have to get the x's to the same side. I chose to move it to the right because that leaves me with a positive x when I add those. So moving my x's to the right means I'd have to move my constants to the left, so I'd have to subtract the 9. Okay, and then doing that leaves me with -1. Okay, now if you moved your 4x to the left and your 8 to the right, you should have come out with -x equals +1, and then you would have to divide out the -1. So you would still end up with x equals -1. Okay, so that's what everybody should have gotten there. On the second one here, you had to distribute first. So that would be 2x plus, nope, minus 2x minus 8 plus 4x minus 3 equals 31. So you have some like terms over here that you can combine. So that is 6x. And then the -8 and -3. So that's -11. That needs to be moved to the other side. So the opposite of -11 would be +11. Okay, so that's to get rid of it over here. Okay, so that comes out to then 42. And then you have to divide out the 6. So you should have gotten x is 7. Any questions about either of those? I'll feel okay with like your basic solving skills. Okay, so that's kind of like what you were hoping to review, some of those basic skills on that part 1 and part 2 linear equations delta math. All right, now here we'll review a little bit of our unit circle knowledge. First of all, it says to give your answers on the interval 0 to 2 pi. But notice there's a bracket on the 0 and a parenthesis on the 2 pi. What does that bracket and parenthesis tell us? Say it again. It's either included or not included, right? Because 0 and 2 pi are coterminal angles, aren't they? They're the same spot on the unit circle. So they're saying if that is an answer, include the 0. 0 would be the answer, not 2 pi. Okay, and you wouldn't list both because it would just be repetitive. So we're going to give any answer between 0 and 2 pi, so 1 revolution around the unit circle. But we're going to include the 0, not the 2 pi. So my strategy here, what I would tell you to do is first figure out what these are asking. Whenever you have a trig function isolated and the missing variable is here, that's the angle that's missing, right? All of these are asking at what angle is sine 1/2? At what angle is tangent 1? At what angle is cosine -√2/2? Okay, so our answers are going to be angles, and we're going to give the answers in radians between 0 and 2 pi. So I'm going to start by determining, first of all, where is sine positive? Because that's a positive 1/2. Where's sine positive? Quadrants 1 and 2. So I know my answers have to come from up here in these 2 quadrants. So I'm going to have multiple correct answers. And I'm going to have 2 answers on this one because there's 2 quadrants where sine could be 1/2. Now then I'm going to ask myself, what's the reference angle? Okay, hopefully y'all remember those 0, 30, 45, 60, 90. that quadrant 1, hopefully you memorize those values. Remember, sine is the y value. So at which of those angles is the y value, the sine, 1/2? It's 30 degrees, or in radians, that's pi/6, right? And then we need the pi/6 reference angle in quadrant 2. So that in quadrant 1, that's just pi/6. And in quadrant 2, that would be 5 pi/6. And you can look at your unit circle. You don't have to have these values memorized. Look on your unit circle at the pi/6 angles, and the y value is 1/2. You do not have to do this little drawing. I'm doing this for the sake of your notes as I explain. Okay, where is tangent positive? 1 and 3. Okay, everything's positive in 1, tangent's positive in 3. Okay, what reference angle is tangent 1? At which reference angle? At a 45, or a pi/4, right? So in quadrant 1, that's just pi/4. And in quadrant 3, that's 5 pi/4. So those are the two angles where tangent is 1. Bless you. All right, what about this last one? Where's cosine negative? It's negative over here. And at what reference angle is cosine square root of 2 over 2? Well, the reference angle is just 45, right? Or pi/4. So I'm looking at the pi/4 angle in both of these quadrants. So yes, it's at 135 if we were in degrees. But remember, we're going to give our answers in radians. So that's at 3 pi/4. And in quadrant 3, that's at 5 pi/4. 3 pi/4 and 5 pi/4. Does that make sense? Okay. All right, now we're going to put those together. We're going to put trig knowledge on the unit circle, this, together with these algebra skills for solving equations. Okay, we're going to have trig equations that we need to solve. Okay, so just like if we were solving for x, we're going to isolate the x. We're trying to solve for a trig equation, so we're going to isolate the trig function. So I want to get tangent of x all by itself. What am I going to do? What needs to move first? That +1, that constant, needs to go to the other side. Opposite operation would be to subtract 1. So I've got square root of 3 times tangent of x equals -1. What now? Divide. Good. That square root of 3 is being multiplied by tangent. It's a coefficient. So we get rid of it by dividing. So I've got tangent of x equals, but we don't like having that radical in the denominator. So I'm actually going to go ahead and rationalize that. Rationalize is when you multiply by the radical that's in the denominator to get rid of it. Okay, so that becomes just a 3 in the denominator. And it's a negative square root of 3 in the numerator. So now I've isolated the trig function, so I'm ready to answer using my unit circle. Where, at what angle is tangent negative square root of 3 over 3? Well, I know tangent's negative in 2 and 4. Square root of 3 over 3 at 30. Remember, 30 has the extra 3 for the tangent. So that's a pi/6. So we need the pi/6 angle from quadrants 2 and 4. That's 5 pi 6 and 11 pi 6. Does that one make sense? All right, let's try this one. What am I going to do if I want to isolate sine of x? What do I move first? The 1. So I'm going to subtract the 1 over to the other side. Now what? Get rid of the 2. It's the coat being multiplied, so I divide. I'm asking myself where, at what angle on the unit circle is sine -1/2? Sine is negative in 3 and 4, and it's sine, the y value is 1/2 at pi 6. So we need the pi 6 referencing the pi 6th angle in quadrants 3 and 4. So that is, somebody said 7, that was correct. 7 pi 6. Good. 7 pi 6 and 11 pi 6. You will not have a graphing calculator, but if you have a scientific or graphing calculator to like check your homework as you're working, you can. If I were to go back and plug this in, this number that I got, and let's say you're not great with your unit circle, you could just type in 2 sine of 7 pi 6 plus 1, and it should come out as 0. As long, and since we're inputting these in radians, you would need to make sure you were in radian mode. But you could check these by plugging them into the calculator. You won't have that on the test though. So far so good? All right, so we're gonna fill in some important ideas in this box, okay? I'm gonna type these in, you can write them down. All right, so to solve trig equations, we said the first thing we want to do is isolate the trig function. Get the trig function by itself. The next thing we'll want to do is use the unit circle to find the angle satisfies the equation. Satisfies the equation means makes it true. Do that. The tips I gave you, the strategy I gave you is to determine the quadrants based on the positive or negative value. And then I determined the reference angle. For the given value, or for that value that you found. Once you know which quadrant it's supposed to be in and what reference angle it is, you either know it if you know your unit circle well, or you can search on your unit circle for it. Something you may want to add, just to remind yourself that bracket 0 to pi, I'll write in the pi by hand, I can't type it, means include 0, not the 2 pi. I have to write in the pi symbol though. Oops. Okay, so 0 to 2 pi with a bracket on the parenthesis means include the 0. The parenthesis means not the 2 pi. Okay, and this is typically the interval that we're going to be giving our solutions on. Something else you may want to put in here when we're determining the quadrants. If you need this reminder, you can write it down. All students take calculus. Remember, that's what's positive in that quadrant. All the trig functions, sine, tangent, cosine. You may also want to remember or jot down that your x is cosine and your y is sine. Anybody else think of anything we might need to jot down to help us remember things? I think that's the main thing you need to remember. All right, so if you flip it over to the back, when you're done writing this down, if you flip the paper over to the back, there's two problems that need to be solved by factoring. I'm going to set another timer for y'all to try those on your own, and then we'll go over them. Okay, if you're watching it on a video, pause, try it on your own, and then come back to the video. Okay, I'm going to freeze the projector screen for those of you in class on these problems. Y'all give them a shot. You can discuss with your neighbor if you need to. All right, That's time. Let's look at this. All right, so in the first one, the A value is an understood 1 right here. Okay, so I know the x squared factors will just be x times x. So then I simply have to find the factors of negative 32 that add to 4. So what two numbers multiply to give us negative 32, but add to give us 4? What'd y'all get? A positive 8 and a negative 4. And we knew it had to be one positive and one negative because C is negative. Okay, good. So that's factored. Now, this didn't just say factor, it said solve by factoring. Okay, so you did a bunch of factoring practice yesterday and you just stopped there once you had it factored. But remember, all of this equals 0. So you split and solve. You set each individual factor equal to 0. And solve them. So here I would need to add 4. So this would become 4. Here I would need to subtract 8. So it would be negative 8. So those would be the two solutions. Remember, you can take your solutions and plug them back into the equation, and it should come out true. The left should equal the right, okay, if those actually satisfy the equation. Hint over here for this one, you should have started with GCF. This is not a quadratic form trinomial right now because you've got an x cubed, an x squared, and an x term. Okay, so I can factor out a 2x, which would leave me with x squared plus x minus 6. Now that is a quadratic form trinomial. Remember, you have that the power on that variable is double this one, and then you've got a constant. Okay, so that is going to be able to be factored in the two binomials. Don't forget the 2x is still out here. So I'm asking myself what multiplies to negative 6. So what are the factors of negative 6 that add to 1? Because this would be an understood 1 right here. So again, I know it's going to be a positive and a negative, right? Because it multiplies to a negative. What did you all come up with? Did anybody get it? A positive 3 and a negative 2. Good. Okay, so once I've got it completely factored, for set equal to 0, we split and solve. So I set 2x equal to 0, x plus 3 equal to 0, and x minus 2 equal to 0. So here I would add the 2, so that's 2. Here I would subtract the 3. Here I would divide the 2, and so that would still be 0. That one had 3 solutions. If you ever want to check your answers, you go plug them back in and make sure that comes out true. Good? All right. So this algebra, factoring and then split and solve, can be used in trig equations as well. Okay, so we're going to do the first couple. I think might be all we have time for. I might have to do those last 2 tomorrow. This might be in a second video. We'll see how far we get. All right, so for this first one, what type of factoring can I do? Is this difference of 2 squares, greatest common factor, quadratic form trinomial? What do y'all think? How could I factor this one? Do these two terms have something in common? Sine, right. They're both sine of x terms. So I can factor out sine of x, the GCF. What's left when I divide sine of x out? 2 sine of x plus, and then what would this be left this term? Just a 1. Okay, now that's all equal to 0. Now I've got it factored. I'm ready to split and solve. So I set sine of x equal to 0. And I set 2 sine of x plus 1 equal to 0. Okay, you solve these individually to get all of your solutions. So over here, sine of x is already isolated. I'm ready to answer the question, where is sine 0? Think about your unit circle. Where around the unit circle is the sine value, the y value, 0? At 0, here. Where else? At pi. Good, or 180, but we're going to give our answers in radians. Okay, so my answers here would be 0 and pi. Should I put 2 pi also? No, because remember 2 pi had the parenthesis. When we were giving our solutions from 0 to 2 pi, we include the 0, not the 2 pi. Okay, so 2 solutions so far. Now over here, when I go to solve this, I would subtract the 1. And then divide out the 2. So I've got sine of x equals -1/2. So I'm asking myself, where is sine -1/2? You need to sketch it, sketch it. Some of you will not have to do that. Sine is negative in 3 and 4, so my answers are coming from down here. And the reference angle where sine is 1/2 is 30 degrees or pi/6. So we're giving the pi/6 angle in these two quadrants, which would be 7 pi/6 and 11 pi/6. So that one has 4 solutions. You feel okay about that one? I think GCF is going to be okay. And because we've actually done some greatest common factor with Trig already when we were doing our identities. We did some of that factoring with a greatest common factor. Okay, but let's look here at this next one. This one's a little tougher. This is not GCF. This is quadratic form trinomial. Okay, you've got a cosine squared of x, cosine of x, and then a constant. Okay, if it helps you to visualize this, to think of this with just x instead of x squared, write it out that way to do your work. If that helps you, if you think that will help you solve it. You do not have to do it that way, but that's the same thing. We're going to factor this cosine expression the same way we would factor this one. Y'all understand that? It's just instead of x, it's actually cosine x, right? I'm actually going to show you a couple of ways to do this one. The a value is not a 1, but it is prime, meaning the only factors are 1 in itself. So I know instead of splitting to x and x, it's going to have to be 2x and x, right? Or in this case, 2 cosine x and cosine x. Those are the only factors of that a term right there. Y'all with me? So now, instead of just asking myself what multiplies to -4 and adds to -7, I have to take into account there's a number here now. Okay, so I have to remember that the outer get multiplied and the inner when I FOIL. So whatever I plug in here is going to get multiplied by 2. Whatever I plug in here, this is an understood 1, right? In front of the cosine. And then they get added together. So you could do guess and check. Okay, so stop writing at this point and just watch. Okay, if I wanted to guess, the factors of 4 are 4 and 1 and 2 and 2, right? So I could just start with 4 and 1. But I know because this negative, one of them has to be negative, right? So I'm just going to start with positive 4, negative 1. And let's see. When I say guess and check, I'm guessing this. Now I'm going to check. Negative 1 would get multiplied by 2. 4 would get multiplied by 1. 4 and negative 2 does not equal negative 7, does it? That means that didn't work. So what if I just change the sign though? Because it could be negative 4 and positive 1. So I'm going to check that. So that would be positive 2 and negative 4. No, that would be negative 2, not negative 7. So I know it's not the 4 and then the 1 over here. What if I switched it though? What if I put the 1 and then the 4? Start positive, negative. So let's try that. Negative 4 times 2 would be negative 8. And 1, would that be negative 7? Negative 8 and positive 1? Yeah, that works. So I factored it. So that's what I mean when I say guess and check. Just plug in some of the possible factors and see if it works. That does now. The first two ones I tried didn't, but that one does. So now you can write that down. Okay, now, if guess and check doesn't make sense to you, and I would only recommend guess and check like this if your A value or your C value are prime, meaning there's only one set of, like 2, we knew it had to be 2 and 1. If neither one of those are prime and you're having to guess both sets and all these different arrangements, that can be more confusing and take longer. Okay, but in this case, 2 is a prime number, so I knew it had to be 2 cosine and cosine. The only one I was having to rearrange was the factors of C. Okay, now I'm going to come back over here. If guess and check is not your thing, you don't want to do that. Grouping, box method, slide divide, any of those will work for factoring this. Okay, so if I did my ACB table, however you organize your ACB table, whether you do like the X like this, the multiplies A times C is negative 8. Okay, you can organize it like this. B is negative 7. So you can do whichever one of these you want, however you want to think about it. What multiplies to negative 8 but adds to negative 7, that would be negative 8 and positive 1, right? Okay, so you would replace the B term with that. So I would rewrite this as 2x squared minus 8x plus 1x minus 4. So you make that substitution in the middle. And then you could create your groups for grouping. And the first group, the GCF is a 2x. And you'd be left with x minus 4. And in the second group, there is no GCF, so it would have to just be an understood 1. So it'd still just be x minus 4. And those came out the same, didn't they? X minus 4 is a factor. 2x plus 1 is a factor. And remember what I said, it's just, we're using x here because it's easier for you to visualize, but just replace the x with cosine of x. You see that? It's the same. 2 cosine of x plus 1, cosine of x minus 4. So doing guess and check or doing grouping, we get the same factors. You okay with that? All right, so remember your factors. This is all set equal to 0. So I'm ready to split and solve. So I'm going to set each side equal to 0. All right. So over here, I would subtract the 1. Divide out the 2. I've got cosine of x equals -1/2. All right, so now I'm ready to ask myself, where on the unit circle is cosine -1/2? Well, I know cosine is negative in 2 and 3, and I know it's 1/2 at a pi-thirds reference angle. So in quadrant 2, that's 2 pi-thirds. And in quadrant 3, that is 4 pi-thirds. So 2 answers so far. Now on the right, I would add the 4 over. I've got cosine of x equals 4. So where on the unit circle does the cosine value equal 4? So if you look at your unit circle and you look at all the x values, remember cosine corresponds to the x value, right? Are any of them a 4? No, they're not. Why is that? Does anybody know? It's not in the range. Okay, so when we say it's not in the range, cosine will never equal 4. If you remember graphing cosine and sine, the wave, remember? It just made this shape over and over and over again, right? The highest it went was 1, and the lowest is -1. That's the range of outputs that cosine of x can equal. Okay, it doesn't exist up here at 4. Okay, so for this side, this factor gave us no solution because 4 is not in cosines of x range, which is -1 to 1. So this is going to be the case. You're not going to get a solution if you get sine of x or cosine of x equal to anything over 1 or less than -1, because sine and cosine have the same range, right? Okay, so no solution from this factor, so just those two, 2 pi-thirds and 4 pi-thirds. Those are the only solutions here. Does that make sense? Okay, we're going to stop there. We'll do the other examples tomorrow, so those will be in the next video if you're watching this online.